Hello everyone, my name is Rod Graham and this is part 2 of our Quantitative Analysis supplemental video. In the first video, we went over downloading PSPP, selecting the data that you should use. Again, that's by your last name. Then we went through the first several questions of your assignment. In this video, we'll go through the last questions, the last 4 or 5, I believe. And these questions are all about producing output in PSPP and interpreting that output. Now, as always, I always like to explain my logic behind the assignments. I know that you will be taking Capstone. You might be taking it now, but you certainly take it in the future. And so this course is meant to be something of a bridge to Capstone. And we don't want students going into that course cold without having any experience with SPSS. And so this assignment is meant to give students that experience. So although you will be producing output and interpreting it, I'll be helping you along in this process with cheat sheets, with this video, by making it so that the data is easy to interpret. I've already sort of pre-selected data for you. So the logic here is to give you that experience, right? That's what we're trying to do. So I think that I've done that. The questions are organized in a way so that it takes you from beginning to end, and at the end you produce some kind of conclusion about your research, right? So let's jump right into it. Here is the assignment, and we left off with me talking about question 5, where you have to select several variables, 3, and one of those variables has to be nominal, another ordinal, and another interval or ratio. And the reason why I do it that way is because, as I mentioned with SPSS, they put, they, as in the programs of SPSS and PSPP, which is what we're using here, they use nominal, ordinal, and scale. And the reason why they use scale is because, for all intents and purposes, the same calculations you would do with ordinal, you would do with interval, and so there's no reason to change, right? Okay, we don't have to distinguish between the two, really. So you need to answer question 5 and select those variables, and you want those variables that you select to be ones that fit with your thesis, your hypothesis, or your research question. All right. So once you've done that, we can now move to the next question. So use PSP or SPSS to calculate an appropriate measure of central tendency. Now, in the text, I talk about, not I, but the author talks about measures of central tendency. That's in chapter 9, so you can go back and you can look at that. Also below, you have a cheat sheet, which links the level of measurement with the appropriate measure of central tendency. Also, it links it to the appropriate visualization method. I'm saying appropriate because, it depends. You have to kind of play it by ear, especially when you're talking about the difference between ordinal and interval, or nominal and ordinal. They kind of sometimes bleed together. So it would be a little silly to say you have to use a pie chart for nominal, or you have to use a bar chart for ordinal. It doesn't quite work that way. But this is a good guide. It's appropriate. And same with this, right? So here are descriptive statistics, where you're describing your data. That's how your textbook organizes it. Inferential statistics are when you're attempting to test something and make a claim about the way the world works. And that's also organized by level of measurement. So in this chart, I've sort of, if you go online, you can see these kinds of charts everywhere. I just expanded it and in some ways simplified it, and in some ways made it a little more in-depth. So you'll always find some chart showing when you should use a chi-square test or independent samples t-test. Here what I did was I said, okay, if you have an independent variable that's nominal and the dependent variable is nominal, then you would do a chi-square test, and this is your test statistic. If you have a nominal that's independent and an ordinal that's dependent, then you also do a chi-square, and you use the chi-square test statistic. Now, I've made this a little more involved by showing every single combination, but it doesn't have to be that way. In other words, it's just more about the combination of variables and not whether they're independent or dependent. So you see nominal, ordinal here, which equals chi-square test. Well, you can see ordinal, nominal here, and it equals chi-square test. So even if you switch independent and dependent variables, it's the combination of the two that produces what method you use and what statistic you should use. So, but these are online everywhere, and they're good and handy to have when you're just figuring out what you should do. Okay, so with the cheat sheets in mind and your variables in mind, you can go about using SPSS to answer your questions. I keep saying SPSS because you'll eventually be using SPSS in your capstone, but know when I say SPSS, I'm also talking about PSPP. I'll try and remember to say PSPP going forward. So use PSPP to calculate an appropriate measure of central tendency for each variable you listed in question 5. So whatever variables you have. My mock assignment does that. And it does it for one variable. That's a nominal variable. And I show the statistics here. And I'm gonna reproduce this output and then show output for another one, just for practice. So I don't use PSPP a whole lot. I've gotten more comfortable using it now for teaching purposes. And so when you do that, you start to learn like pet peeves, like where you should go all the time. So for me, the first place I start is going to always be analyze descriptive statistics, and I go from there. So I want to get measures of central tendency. I'm going to go analyze descriptives frequencies. You can find some of the same data, or you can calculate these same statistics for some variables here, but I just find this tab to have so much in one spot, so I'll just stick with this. PSPP is like any other application. Like Excel, there's some Excel wizards, and they can put together all these pivot tables and all these formulas, and they can turn Excel into this amazing thing we've never seen before. And other people like me, all they can do is just put together some simple columns, right? And so I think most software is that way, and PSPP is no different. There are a lot of things here that you'll never use or will never apply, but you just need to know where you need to go to get what you need. So in this case, descriptive statistics is where you should start. So descriptives, frequencies. All right, and then you get this screen. I tend to like simplicity, and so in my output, and I'll show you the output in a second, I like simplicity. So what that means is I don't want a whole bunch of numbers produced when I push the OK button here. So first, let me make sure I answer my question, and then I'll start cleaning up the output. So I am attempting to get the median for the mode, for a nominal variable, which is the appropriate statistic. So let me go back. And the nominal variable is gender. Where is gender? Gender. All right. So you got all these options. So I'm interested in mode. Now there are two ways to go on this. You can leave all of the statistics there and then write about the one that matters. You can do that if you want, or you can just select the one that matters, that you think matters. Either way, you still have to write about the right one. So you're not getting over by just listing all the statistics. You have to choose the one that matters. So since I want to have a little clean output for the reader, and I know I want mode, I'm just going to click mode. Okay. Now there's also the option for a frequency table showing all the values. For mode and for nominal and ordinal variables, I like the frequency tables, so I'll keep them. And I'll show you how ugly it can get for other variables, the scalar variables, in a minute. But for nominal and ordinal variables, keeping the frequency table is fine. So, okay, I've got age. I've selected my statistic. I'll click OK. And then let's go to the output. And this is what we've got. We've got the mode here, which is female. Now, from your reading, or just from other classes, you know that mode is the most numerous. So for this one, we have more females than males. So that's the mode. And you know what? Now that I'm doing this, I think in my actual assignment, mock assignment, I looked at something different. Yes, I asked the question, do you ever use any of the following social media sites? And then, I gave the information for this. So that's fine. So here in your mock assignment, you got one variable. Here on the video, you got a different variable. So you got two different examples. But it's the same process, right? You produce the statistic, you select what matters, and then you write about it. All right. So let me do one that, or produce output that probably is not, it just shows that you don't know what you're doing, maybe. It won't be wrong because you're giving everything, but it might show that you're not quite clear on what you're trying to accomplish. So let's take out gender, and let's put context, or values on text scale. Let's do that one. And then I click mean, mode, median, just click them all, kurtosis, skewness, all these different statistics. And I don't think about the frequency table. Just run it all. And then I click OK. Okay, well, it's going to give you some stuff. Mean, median, mode. There is no mode. You probably don't know why. If you did this, you don't know why. You guys who know the difference, or why mean, median, and mode measure different things, you know why it says no answer for mode. Because every value is 1. There's no most numerous value. And look at all of the values. So the frequency table gives you every single value. This is simply too much. You're not going to show that to anyone. So it makes no sense to show a frequency table there. All right. Now, on my desktop here, I can use Snip and Sketch. And so what I tend to do is after I produce the output that I like, I open up Snip and Sketch, and then I take a screenshot of what I need, and that's it. And then I copy that and put it into my assignment. And then this is just me now. I close out output. You don't have to do that. You can just keep output open and keep adding output. But I don't know. I mean, I don't want to have to keep scrolling down. So I'll just erase it and then generate new output. Okay, so that's that question. Okay, you can do that for all of them. For ordinal and interval ratio, you just have to choose what fits. So the next thing you have to do is visualize your data. Now, I've got examples here. One thing I should point out is that on PSPP, it's easier to get a histogram. If my memory serves me correctly, on SPSS, it's easier to get a line graph. But they're really the same. I mean, as far as I can tell, the line graph is just a smoothing of the bars on a histogram, right? But I could be wrong about that. But I think that's what it is. So in this assignment, I'm saying histogram or line graph, and I give you the example of the tech value score, and this is what you get. Let's go through that. So I'm going to go back to Analyze, Descriptive Statistics, and frequencies again. This is like the most commonly used tab, is that frequencies. And I'm going to kind of clean all this out, and I'm going to do charts. And the histogram, and so here everything is here actually. The histogram is for the histogram / line, then you got the bar, and you got the pie. The question is, what way are you going to visualize the data that makes most sense. So sometimes it's just trial and error. You can even do 2 at one time and get a look at it, or all 3. So first, let me do something. Let me remove the frequency table. We're not going to need it right now. And I'm going to do race and ethnicity. Let me remove tech value score. And I'm going to do it for all 3. Now, here's the thing I've noticed about PSPP. It's a big drawback. It doesn't produce, at least on my computer, the nicest charts. So if you give me something that looks, really, really odd, it's probably not your fault. It's just that this software was written for a GNU operating system or even a Linux operating system. And so it may not necessarily render as well on your PC. But that's okay. All right, so I'll know. So click continue and OK. And you get these findings. Right? And it looks really terrible. I mean, I'm not quite sure why it's doing that. And it might be something in options that I can change, but I just haven't figured it out yet. But here's the thing. You need to figure out an appropriate visualization. So this is a nominal variable, and so that often means that a pie chart is the best, but it doesn't have to be. Maybe you might say, wow, you know what, I want to illustrate the size difference between the number of white respondents and the number of blah, 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 blah respondents, right? And so you may say a bar chart is the best, right? You have to make that choice. This is not a good choice. The histogram makes no sense, right? So if you use that, I know you don't know what you're doing or you're not paying attention. So it would have to be one of these 2. I want to look at my assignment here and make sure that I made that clear. Yeah, okay, so here you've got level of measurement, nominal, and I got mode. I want to put mode and median here. Wait, no, that's fine. Actually, I want to keep that here. Make sure that pie chart and bar chart is here as well. Because who knows? I mean, someone might have a nominal variable like race and ethnicity, and they want to show it as a bar chart. So I want to put that there. I have frequency table here. You can use that, but I'm not asking you to. It's an appropriate visualization method, but I'm not asking you to produce that in this assignment. Okay, so that's the visualizations. Now, let's move to testing hypotheses. All right, in question 4, this one, I asked you to state a bivariate relationship. Now, these things are stacking onto each other. You started with a research question in question 3, or a hypothesis. Then in question 4, you need to be explicit and find variables in the data set that will allow you to answer your research question or test your hypothesis. So that's question 4. Now in question 8, you need to generate some kind of statistic that allows you to see whether or not your hypothesis is accepted, or you can answer something about your research question, right? You get the answer to your research question. So to do this, you need to use this cheat sheet. So the top table is descriptive analysis or descriptive statistics. You're generating statistics that allow you to describe the actual variables in your data set. This chart is inferential statistics, meaning that you are generating some kind of calculation, some kind of statistic that will allow you to make some kind of claim, some kind of inference about what's going on in the real world. So you got this data set. I'm going to show you the code book here to make this clear. You got this data set that asks about 1,000 teens between the ages of 13 and 17, all kinds of questions. But you don't want to know just about those teens. You want to make some kind of claim about the world in general. In this case, the world of teens ages 13 to 17 in the United States, right? Okay, that is where these tests and test statistics come in. So each test has a particular statistic attached to it. Now, you may have taken a stats class where you would by hand calculate some of these statistics. I think chi-square is a very popular one. Here, of course, you're not going to do that. And really, you're not going to spend a lot of time interpreting this information. Instead, I just want you to get practice generating that information so that when you go to capstone, you're not going in cold. And also, you'll be familiar with these terms: chi-square test, independent sample t-test, Anova, and correlation. And I'm going to go through all four of these, and I have examples in my mock assignment. Now, what does this less than 0.05 mean? Okay, now statistics is all about probability. And this idea is that, in simple terms, the idea of less than 0.05 is that the relationship that you find, if you find one, the relationship that you find between these two variables, we expect 95% of the time to find in the population. So whatever value it is, you won't worry so much about the values of how one thing affects another. That comes at a later time in your career at ODU. But right now, whatever, if there is a relationship and that test statistic is less than 0.05, that means that in the real world, you will find that relationship about 95% of the time. So we're confident that if we think that gender matters for social media in the sample, 95% of the time, we're going to see that in the real world. That's the idea in another sample that you might take, if you want to think of it that way. So for those of you who asked a hypothesis, the 0.05 would be interpreted as, my hypothesis was supported. There is a relationship between Instagram and thinking that guns are a bad thing or something. I don't know. For those of you who asked a research question, you might describe it differently. You may say, well, the relationship is significant at the 0.05 level, and so that means that, okay, there is a relationship between race and posting things on Tumblr, whatever it may be, right? So it all depends on the question you ask or the hypothesis you make, how you talk about this. Okay, so let's generate these statistics. And I'll go and I'll do all four, and I'll start with the chi-square test, which is nominal and nominal. So going to my data here, and I actually want to close this out. So again, we go Analyze and Descriptive Statistics one last time, and we go to crosstabs. All right, so you have two nominal variables. One will be on the row and one will be on the column. What did I do in my assignment? Let me be consistent here. My mock assignment, what did I use? Gender and SNS1, Twitter. Okay, so I'm going to do the same thing here. So I went to crosstabs, and I'm going to put gender on the rows. That's traditionally the independent variable space. And then Twitter in the columns. Now you've got things that you can change here, and I suggest we make those changes. First, let me show you the statistics. This is the chi-square statistic. That's almost that's the one that's used the most, so it's kind of checked by default. But you've got others, and if you're in a grad program and you're working with some unique data, then you may come across an occasion where you have to use phi or lambda. For those really good students, and you remember the difference between parametric and non-parametric statistics from your either statistics class or from this class in your book, then when you have non-parametric data, then maybe you want to use phi, I think. But for us, chi-square is fine. So let me close. Oh, where is it? I've lost my... okay, here we go. It's weird. Okay, now I want to change the cells. This is, again, just to make it easier to read. So with crosstabs, you want the cell count, and you don't need the row count, you don't need the column count. I like the expected count, and you'll see why after I run this analysis. So count, total, and expected. That should be fine. continue, and OK. So this is what you should see on the mock assignment. And you've got the N, 743, no missing cases in the analysis. So the actual counts, and this is pretty easy to incorporate and interpret. Males said no, they didn't use Twitter 237 times. Males said yes 111. Females said no, they didn't use Twitter 256 times. And yes 137. Okay, now what the chi-square statistic does in a general sense is it imagines how those cells would be filled if everything was random. And that would be the expected count. So the expected count, if everything was random, would be 231, not 237. It would be 116, not 111, and so on. And then you use some math, and you do all these calculations, and then you come up with a Pearson chi-square test statistic, which is this. If that test statistic is less than 0.05, then you can say, there is a relationship here. But obviously, it is nowhere near 0.05. So there's just really this is just random. There's no relationship between gender and using Twitter. Okay, let's do another one. I'm going to go down the list here. Here is the independent samples t-test. And this is when you have a nominal and an interval ratio variable. And so let's do that here. So now I'm not going to look at what I did on my sample assignment, mock assignment. I'm just going to do a different one. So now we move from this very famous tab. We now have to look at a different place. So now we need to go to compare means. And it's going to be independent samples t-test. Now you may say, well, where are you getting this from, Dr. Graham? I don't see any instructions for this. Well, there isn't any, and I'm not going to give any. Just follow this, and that's enough. If you want some extra instruction on SPSS, maybe you want to do an assignment outside of class, I can certainly help you. But for this, just kind of follow my lead. So compare means, independent samples t-test. And t-tests always work with two groups. That's why its nominal is always the best. So gender can go here. And I'm going to look at hours per week. I don't think that's what I used in my mock assignment, so I'll use it here. So this is going to be the grouping variable, which generally is the independent variable. And this is the dependent variable, hours per week. How many hours per week are you on a cell phone, right? So then you go to define groups, and it's always going to be two with independent samples t-test. So male and female. And click continue. If you had used an ordinal variable here, then you would simply have to choose two of the values from the 3, 4, or 5 values in your ordinal variable. So you can still do it, but there are better tests with the ordinal variable. So here's the t-test. Push continue, and let me see if there's anything I need to do here. Nope, we're gonna do that 95 confidence interval. That's fine. That's fine. Okay, push OK. All right. Now, to make this a bit simpler here, let's look right at this. Oh no, sorry. Let's look right at this. Significance is two-tailed. So I think technically you would start with the Levine's test for equality of variances, but most of the time you can simply assume equal variances, and let's not worry about that. Let's assume equal variances and look at this top line here and look for the significance value. And so here we've got 0.038, which is less than 0.05, meaning that there is a relationship between hours per week and gender. Now we'd have to go and look more closely to understand what that relationship is, and I can kind of tell you right here. See, the mean for female is 21 hours per week. So females are on their cell phones 21 hours per week, and men 20. And that relationship, we think, is strong enough within this sample that it will appear again 95% of the time outside of the sample. So if we did the same research again with 1,000 students, we'll get that same response. And then again, I'll get that same response and again. So that tells the social scientist that, there really is a relationship here, right? So this is significant. So if you do an independent samples t-test, just look at the first line. We won't worry too much about this other stuff. So the example that I used was different, and it was not significant, right? So, both are fine, right? You can look at this one and get an answer, or you can look at another one. Okay, so now let's do the last two, Anova and Correlation. I'm going to leave it. I'm going to close this output. I don't know why. I'm like OCD or something, but I don't like a messy output screen, so I keep closing it. So analyze. Now we're going to do analysis of variance. So Anova stands for analysis of variance. And I'm going to compare means again. And this time it's a one-way Anova, one-way analysis of variance. And with the Anova, you can use a nominal variable, but if that nominal variable is two categories, then you might as well use independent sample. But it's also good for ordinal variables as well. I'm going to use another nominal variable. Oh, excuse me. I'm going to use another. Oh no, actually, I'm going to use an ordinal variable for this, and that's going to be grade. So I'm going to put grade here. And then I'm going to look at hours per week again. Actually, you know what? I'm going to play a little bit because grades, I think, is what I used in my assignment, mock assignment. So I'm going to put parent education here. All right. And for this, let's just run it this way. It might be that in future assignments in another class you would do this, the post hoc contrasts, but we don't need it here. We're just looking for one statistic. So what I'm hypothesizing here is that there's a relationship between parents' education and the hours per week that a kid is using their cell phone. And click OK. All right, so that's all you need. And what we see is that, no, there is no relationship because the significance level here is 0.782, way above 0.05. Okay, and this is called the F statistic. That's probably not obvious from looking at that, but that's the F statistic. Okay, so let's do one more. And I want this to be the Pearson's correlation coefficient. So this is when you have two scalar variables. And so we kind of understand this intuitively because this is something that we've probably seen in other classes, right? Where one variable rises, then another variable rises, and that's a positive relationship, and one rises and the other variable decreases, and that's a negative relationship. This type of thing. So we kind of know about this type of thing. We know about the Pearson's correlation coefficient. In class, I would talk about strengths of correlations and all that, but here I just want you to calculate the statistic. So let's go here. Let's pick two scalar variables. Now, for this one, you're going to go to bivariate correlation. And you're going to choose two scales. I'll do values on text scale, and I'll do age. Okay. And I think that's enough. There's nothing else we have to do. This is going to be a pretty simple output here. Click OK. Okay, so we're looking at the significance, two-tailed significance here, and it's 0.419. Now, you may see another significance here, and it's also 0.419, but that's just because it's the reverse. It's just the inverse of what you see in this cell, right? This is like they're calculating values versus age in this cell, and then they're calculating values versus age in this cell, and so you're just getting the same numbers because it's the same values. So this is not significant. It's 0.419, so it's above the 0.05. So that means that there is no relationship between age and values on text scale, right? So if you had a research question that asked, is there a relationship between values on text scale and age, you would say, no, there isn't. If you had a hypothesis that you said, well, I believe that, values on text scale is positively related, age is positively related with values on text scale, then you look at this and you go, oh, no, I was wrong, right? So that's kind of how it works. So, all right, I think that does it. I'm going to look over my assignment again to make sure that I don't have any typos, and there may be some small changes, but nothing that would impact this video. So if you have any questions, shoot me an email and maybe I can handle it that way. If not, then we can set up a Zoom meeting. Otherwise, have a good day.